Welcome back, everybody, for another deep dive. This time, we're tackling a real head-scratcher. We're going to try to connect quantum entanglement, time, and even consciousness. And we've got a whole bunch of stuff to dig through, research papers, articles, even some pretty out-there theories.
It's quite the mix.
It is. It really is. It's going to be a wild ride.
Yeah, it's like we're putting together one of those really weird, like, 1,000-piece puzzles.
Right.
But those pieces, they don't quite fit the way you think they should.
Yeah.
But I think that's what's really exciting about this, is that we're venturing into the unknown here.
Yeah.
Where the lines between these topics, quantum entanglement, time consciousness, they all start to get a little blurry.
Yeah, definitely. So let's start, I guess, with the basics for folks who might not be as familiar with quantum entanglement. What exactly is it, and why do people call it spooky action at a distance?
So quantum entanglement, okay, so imagine you have two particles, right? And they're linked together. And it doesn't matter how far apart they are. These particles could be on opposite sides of the universe. But if you measure the state of one particle, you instantly know the state of the other. It's like they're communicating faster than the speed of light, which we know from classical physics is like the ultimate speed limit. So it's kind of mind-boggling.
Yeah, it's like they're connected by like an invisible thread.
Right. Exactly.
So how does this spooky action at a distance, as they call it, how does that connect to something like time travel? Is that even scientifically plausible?
Well, it's definitely at the edge of what we understand right now. But there are some very, very interesting hints. Have you ever heard of retrocausality?
Retrocausality. Vaguely. But maybe you could explain it for our listeners.
Sure. It's a very strange idea. The idea that an action in the future can actually influence something that's happened in the past.
Whoa, okay, so like sending a message back in time, like changing the course of history.
Not exactly. Think of it more like influencing the probabilities of things that have happened in the past. You see, in the quantum world, things aren't set in stone until they're measured. So retrocausality suggests that a measurement we make of the future could somehow ripple back in time and affect the chances of certain events happening in the past.
Okay, so it's not like Marty McFly going back and messing everything up.
No, not quite that dramatic. Although it is pretty dramatic in a way.
Right. But you're saying this isn't just theoretical. There are actual people looking into how to make this happen.
Yeah, actually. There's a lot of research going on right now exploring how retrocausality might be possible, especially using quantum computers. There was even this one experiment, I think it was described in New Scientist, where they actually tried to send a particle back in time. Now, they didn't quite achieve time travel in the, science fiction sense.
Right.
But it shows you how scientists are really pushing the boundaries of what we thought was even possible.
Wow, that's pretty amazing. So we've got quantum entanglement potentially affecting things across time. What about black holes? I always hear those brought up in discussions about time travel, too.
Yeah, black holes are like the ultimate mystery, right?
Yeah.
These incredibly dense objects with so much gravity that they warp the fabric of space-time itself. And there's this thing called the Kerr metric. It's a mathematical description of the space-time around a rotating black hole.
Okay.
And what's really weird is that the Kerr metric suggests that inside a black hole, the past, the present, and the future, they could all get so distorted that they basically become like one big jumbled mess.
Whoa, so if I were to fall into a black hole, hypothetically speaking, I might see like snippets of the future.
Theoretically, yes.
Yeah.
But surviving that trip is, well, let's just say it's highly unlikely.
Yeah, I think that's the least of our worries at that point.
Right. It's more about the idea that inside a black hole, our normal understanding of time just completely breaks down.
Okay. Yeah, no, I got it.
There are actually some research papers out there by a couple physicists named Grib and Pavlov, and then another one by Grib and Ruslova, that go into this concept in a lot of detail. Really fascinating stuff.
Sounds like it. So black hole tourism maybe isn't in the cards for us quite yet. Are there any more down-to-earth ways that we might be able to navigate through time?
There are some very cool ideas out there. The universe is constantly expanding, right?
Right.
That means the space between atoms is always growing, and that creates a measurable difference between different points in time.
So you're saying that if we had technology that was sensitive enough to like detect these tiny changes in space, we could actually pinpoint moments in time.
That's the idea. And there's even evidence that these changes in space are connected to major events in the universe. For example, scientists have noticed that the decay rate of manganese-54, which is a radioactive isotope, it starts to change 36 hours before a solar flare happens.
Yeah.
It's like it's somehow getting a sneak peek at the expansion of the universe that's caused by the flare.
Wow, that's wild. So does that mean we could like Predict solar flares?
It's a possibility, yeah. And when you start thinking about gravity waves, things get even more interesting.
Okay, I'm all ears. What do gravity waves have to do with time travel?
Well, gravity waves are these ripples in space-time,
Right.
and as the universe expands, the space between those waves also expands. So some scientists think that by analyzing these expanding gravity waves, particularly the ones emitted from future events like supernovae, that we could actually pinpoint specific points in the future. It'd be like using them as markers on this giant cosmic timeline.
So we could, like, see ripples from a supernova that hasn't even happened yet.
Exactly.
That is seriously next level. But how would we even detect gravity waves from the future?
Well, there's this really cool project called NanoGrav. It stands for North American Nanohertz Observatory for Gravitational Waves.
Of course. Catchy name.
It is, and basically what they do is they use these radio telescopes and pulsars, which are these incredibly precise cosmic clocks, to study low-frequency gravitational waves. And by analyzing how these waves interact with the pulsars, they can learn all sorts of things about the fabric of space-time, and potentially even find those future markers that we were just talking about.
Wow. So nanograph could be like the key to unlocking the secrets of time travel.
Who knows, maybe.
It's pretty crazy to think about. Now, how does all of this, like, tie back to quantum entanglement? We've gone on this whole journey through time and space.
Right back to entanglement. Well, there's some really groundbreaking research happening right now that shows that if you manipulate quantum entanglement in just the right way, you can actually simulate time travel in a quantum system.
Simulate time travel? Wait, are you saying we can, like, create time travel in a lab?
Well, it's not about sending a person back in time or anything like that. It's more about recreating the effects of time travel in a controlled environment. Think of it like this. Entanglement is this bridge that connects different points in time. So by manipulating the entanglement between particles, scientists can actually make information appear to flow backwards in time.
So, like, reversing cause and effect.
Exactly.
Yeah.
And there's some really interesting papers out there that go into a lot more detail about this. There's time-reversed light emission from optically driven quasiparticle wave packets, and another one called retrocausality, how backwards in time effects could explain quantum weirdness. If you're interested in learning more, those are definitely worth checking out.
Well, I'll have to link to those in the show notes. This is seriously mind-blowing stuff. We've gone from spooky action at a distance to black holes to time travel simulations in a lab, all in the span of, like, what, 10 minutes?
It's a lot to take in, that's for sure. And we're not even done yet. We still have to explore the biggest mystery of all, consciousness.
All right, yeah, let's get into that. How on earth is consciousness connected to all of this, to quantum entanglement and time?
Well, there's this growing idea that quantum phenomena might actually be happening inside the human brain, and that these quantum processes might be directly linked to consciousness itself.
Wait, are you saying that our brains might be using quantum entanglement? Like, what would our brains even be entangled with?
That's the really intriguing part, right?
Right.
Some researchers have suggested that our brains might be entangled with, well, everything. That consciousness might be this interconnected web of quantum entanglement that spans the entire universe.
Wow, okay.
Others have pointed to something called a Schumann resonance.
Schumann resonance? I'm not familiar with that.
It's basically these electromagnetic frequencies that are generated by lightning strikes in the Earth's atmosphere. And some researchers believe that these frequencies could actually be a source of entanglement for human consciousness, almost like a global consciousness network.
So our brains could be tapping into a global consciousness network created by lightning.
That's amazing.
Yeah.
What other evidence is there to support the idea that there are quantum processes happening in our brains?
Well, there was a really interesting brain experiment, I think it was featured in a Big Think article, where researchers think they might have actually witnessed entanglement happening inside the brain.
Really?
Yeah, it's still very early stage research, but it's very, very intriguing. And then there's the whole thing with lithium treatment.
Lithium, you mean the medication? What does that have to do with entanglement and consciousness?
So some researchers believe that lithium's effectiveness in treating certain mental health conditions could be related to how it interacts with this thing called chiral entanglement. It's a specific type of entanglement that some scientists think might be essential for how our brains work. And they believe that lithium might be influencing this chiral entanglement in a way that leads to the therapeutic effects that we see. Wow. That's a lot to process. We've covered so much ground already, from quantum entanglement to black holes to the possibility that our brains might be using quantum processes. It's really amazing. Where do we even go from here?
I think the biggest takeaway is that All of these ideas that we often think of as separate, quantum physics, time, consciousness, they're actually deeply interconnected. They're not separate fields of study. They're really just different facets of the same underlying reality. And we're just starting to scratch the surface of how it all fits together.
That's such a good point. It's like we tend to put knowledge into boxes, Like this is physics, this is biology, this is philosophy.
Yeah, exactly.
But really, it's all connected.
It's all one big, beautiful, interconnected mess.
Yeah. And the more we can blur those lines between disciplines, the more we can learn about the nature of reality itself.
I think so. It's an incredibly exciting time to be exploring these ideas.
Yeah.
And who knows what amazing discoveries might be waiting for us just around the corner.
Yeah, it really is. It feels like we just took a crash course in, theoretical physics and the mysteries of the universe. So much to dive about.
It's a lot to take in all at once, for sure.
It is. Maybe we can try to, summarize what we've covered so far. We started with quantum entanglement, which is, this bizarre phenomenon where two particles are linked no matter how far apart they are.
Yeah. Measure one and you instantly know the state of the other, even if they're light years away.
Exactly. And then we explored how this spooky action at a distance might have some crazy implications for how we understand time.
Right. We talked about retrocausality, the idea that actions in the future could actually influence the past, and how manipulating entanglement might even allow us to simulate time travel effects in a laboratory setting.
Right. And then we took a trip to the realm of black holes, where gravity is so strong that it warps space-time so much that our normal understanding of past, present, and future kind of goes out the window.
And those black holes, they really do challenge our understanding of time. It's almost like time itself gets twisted and turned inside a black hole.
It's pretty mind-boggling to think about. We even touched on some more down-to-earth ways we might be able to navigate through time, like analyzing the expanding space between atoms.
Or studying the patterns of gravity waves coming from future events.
Exactly. And then we dove into the mysteries of consciousness, the idea that quantum processes might actually be happening inside our brains.
It's a really wild concept to think about. The possibility that these quantum phenomena, like entanglement, might be happening at the level of our neurons.
And we talked about the Schumann resonance as a potential source of entanglement for human consciousness.
Right, almost like this global consciousness network created by lightning strikes in the atmosphere.
It's almost too much to wrap your head around. And then, of course, we talked about lithium and how its effectiveness in treating certain conditions might be linked to its influence on chiral entanglement in the brain. So many possibilities, so much to explore. I think one of the most mind-blowing takeaways for me is how these concepts, which we often think of as being totally separate, like quantum physics, time, and consciousness, are actually deeply interconnected.
It really highlights the idea that we can't just look at these things in isolation. Everything is connected. It's all part of the same grand tapestry of reality. And as we continue to investigate these connections, we might completely transform our understanding of ourselves and the universe.
It feels like we're on the verge of, a huge scientific revolution.
I think so, too.
Yeah.
And with these huge potential breakthroughs comes this huge responsibility, too.
Right.
I mean, if we could actually access information from the future or manipulate time, think about the ethical implications. What kind of responsibility would come with that kind of power?
Yeah, that's a really good point. It seems like any technology powerful enough to, unlock the secrets of time and consciousness, it would also have the potential for huge misuse.
Right. How do we make sure these advancements are used for good and not for, causing harm?
That's a question we need to start thinking about now, not later, right?
Absolutely. We can't wait until it's too late. We need to start having these conversations now as a society to figure out how to navigate these potentially world-changing discoveries.
It's not just about the risks, though, is it? There's also this huge potential for good.
Oh, absolutely. I mean, think about it. Imagine a world where we could use entanglement to develop new forms of communication that could, transcend time and space.
Wow.
Or what if we could create more effective treatments for neurological disorders by harnessing the power of quantum processes in the brain?
The possibilities seem endless. It's a lot to think about, both the potential risks and the incredible potential benefits. I guess the important thing is that we have these conversations, right? We can't shy away from the tough questions.
I think that's right. We need to engage in this ongoing exploration and consider all the implications, because ultimately the future isn't something that just happens to us. It's something we create. It's a collaborative effort.
Yeah, that's a good way to put it. It's not just about a few brilliant scientists making discoveries in a lab.
Exactly.
It's about all of us, sharing knowledge, questioning assumptions, and working together to try to understand these huge mysteries of the universe.
I think that's a great way to look at it.
So what can our listeners do to, stay involved in this ongoing exploration?
There are so many ways to get involved, even if you're not a scientist. You can read books and articles, watch documentaries, attend lectures, and most importantly, never stop asking questions.
Question everything, right?
Absolutely. Challenge the status quo. Think critically. Be open to new ideas. You never know where your curiosity might lead you. And who knows, you might even make your own contribution to this field.
Yeah, exactly. You don't have to be a scientist to make a difference.
Right. And there are even citizen science projects where people can actually contribute to real research. Plus, there's so many online communities where you can connect with others who are interested in these topics.
It's all about connecting with others, sharing your passion, and learning together.
Exactly. The more we learn about the universe, the more amazing it becomes. The most important thing is to stay curious, stay informed, and never lose that sense of wonder.
I know, right? It's amazing to think about everything we've talked about in this deep dive. And, we started with what seemed like completely separate ideas.
Yeah.
Quantum entanglement, time travel,
Mhm.
consciousness. But the more we talked, the more I realized just how connected they really are.
It's true. They really are all intertwined. And it just goes to show how much we still don't know about the universe.
Yeah, and how much there is left to discover. We talked about some really mind-blowing concepts.
I think I did.
Like the fact that entanglement might have implications for time travel, and the idea that our brains might be using quantum processes. But honestly, I think the thing that's really stuck with me is how these discoveries, they touch on some of the biggest philosophical questions that we face as humans. Really big questions.
Yeah, absolutely. Like, what is consciousness? What does it even mean? And where does it come from? Does it exist outside of our physical bodies? If consciousness really is connected to this quantum realm, then it brings up all sorts of questions about the nature of reality itself. Like, do we have free will? Is everything predetermined? And is there some kind of universal consciousness that connects us all?
It's a lot to ponder. And, these aren't just abstract philosophical debates either. If we actually figure out how to manipulate entanglement to influence events across time or to use quantum processes in the brain to treat neurological disorders, that would have huge real-world implications.
Oh, absolutely. We're talking about things that could revolutionize healthcare and technology.
And maybe even change what it means to be human.
It's pretty exciting and also a little bit daunting, to be honest.
It is. It is. We did talk about some of the ethical considerations, but I'm really curious, what are you personally most excited about when you think about the future of research in these areas?
That's a good question. For me, it's the potential to finally answer some of the biggest questions that humanity has been asking for centuries. How does time actually work?
Yeah.
Are we really connected to something bigger than ourselves? These are questions that have been pondered by philosophers and scientists for as long as we've been around. And now it seems like we might actually have the tools to start finding some answers.
It really does feel like we're standing at the edge of a whole new frontier. Anything is possible. So for our listeners who are maybe feeling inspired by this conversation, who want to learn more and kind of stay engaged with this, what advice would you give them?
I would say, first and foremost, never lose your curiosity. Keep asking questions, keep learning. There are so many resources out there, books, documentaries, lectures, online communities, and don't be afraid to really dive deep into these topics. Challenge your assumptions, explore different perspectives, be open to new ideas. The more you learn, the more you realize how much more there is to learn. And who knows, maybe you'll even make your own discoveries along the way.
It's true. And I think that's a great point. You don't have to be a professional scientist or a researcher to appreciate these things.
Not at all.
Right. Anyone can experience that sense of wonder and excitement that comes with, exploring the mysteries of the universe.
Yeah. It's a reminder that we're part of something much bigger than ourselves.
Yeah, I love that. Well, I think that's a perfect note to end on.
It is.
Thank you so much for joining us today for this incredible deep dive into quantum entanglement, time, and consciousness. We covered a lot of ground, and I hope our listeners enjoyed the ride.
It's been a pleasure.
And to everyone listening out there, keep exploring, keep questioning, and never stop being curious.
Right. Stay curious.
We'll see you next time for another deep dive.